Welcome everyone to this lecture on the chapter of laws of motion. Today we are going to cover the topic of pseudo force. So pseudo force is one of the topics which helps us in solving various problems which we face in this chapter, particularly the problems in which our frame of reference is moving. So how does pseudo force helps us in that? So let us learn uh, and jump right into the topic. So let us take a case of a block. This block is kept on some horizontal surface, and we are trying to observe this block from a frame of reference, let's say S. So this frame of reference is at rest and it is observing this block also at rest, that this block is not moving. So the frame of reference S is observing that the block is not moving, and therefore its conclusion is that the net force acting on the block of mass m has to be 0. So this should be followed from Newton's first law, right? From Newton's first law we can say that as though external force is acting on the mass m, then its state of motion must not change. So its state of motion is not changing with respect to this frame of reference S. So such frames of reference are called inertial frame of reference, in which Newton's first law is followed. Now let us take a new frame of reference, let's say S dash, and now we have to concentrate and we have to learn something new. In the previous frame of reference, things were pretty easy, right? The block was at rest, the frame of reference was at rest, Newton's first law was being followed. In this frame of reference, the new frame of reference, which I have drawn just below, this frame of reference is moving, let's say, to the right direction with an acceleration vector a vector. Let's say it's moving with some acceleration a. So the frame of reference S dash would see the mass m coming towards it, right? It would see the mass m, as you can imagine here. Let us draw m again. So as S dash is moving toward m, if we are sitting in the frame of reference of S dash, we would see that m is coming towards us, and not only it would come towards us, it would come towards us with an acceleration a vector, even though it is in rest in ground frame of reference, but with a frame of reference which is accelerating towards right with an acceleration a, mass m would be moving towards this man who is in this S dash frame of reference. So okay, now up till now things have been pretty clear, right? And this follows from general observation too. Once a car is accelerating on road, you would see the pedestrian standing on the road coming towards you. That's pretty obvious to see. Now where things start to turn in some other direction is that when we apply Newton's first Newton's law in this particular case. So as per Newton's first law, if a mass is having some acceleration, there should be some force acting on that mass, right? So in the frame of reference S dash, this man is seeing that mass m is coming towards it. So the man is seeing mass coming towards it, and not only coming with a constant velocity, with an acceleration minus a vector. So the question comes that where does this acceleration come from? Which force is producing this acceleration? Now it may seem pretty obvious that yes, since we are moving with an acceleration a, it should be of no doubt that m should come towards the mass m with an acceleration minus a. So is there any force acting on mass m which is producing this acceleration, or just because we are moving it is coming with an acceleration minus a? So when we talk about Newton's laws of motion, they have to be applicable in all frame of reference. and as you can see, it is not applicable in frame of reference S dash. So these frames of reference in which Newton's first law is not applicable is called non-inertial frame of reference. Usually accelerated frame of reference or rotating frames of reference are non-inertial frame of reference, and Newton's first law cannot be applied. So now what we want to do is that we want to apply Newton's first law or all laws of Newton's in this frame only. We would say that okay, we are sticking with S dash frame. We are not able to apply, not able to write the equations. That's okay. But what if we want to write? So what we do is that then we introduce the concept of pseudo force. So pseudo force is an imaginary force. Like you say, like you would be seeing that there is no net force acting on mass m, right? But still the mass m is accelerating towards this man with an acceleration minus m. So what we say is that whenever we are sitting in a non-inertial frame of reference which is having some acceleration a, we'll add an additional force F pseudo. So let's say this is the force which we are adding, F pseudo, this vector, to the existing forces acting on the particle, and sum of all these existing force, sum of all the real forces, we would say, the real forces plus the force which we are choosing to apply in a non-inertial frame of reference must give mass times acceleration which we are observing in the non-inertial frame. So this pseudo force can be applied in a very simple way, and again this is the point where we have to concentrate. So the applying of pseudo force is pretty simple. What we do is that we reverse the acceleration of the frame of reference. So in case the acceleration of frame of reference is a, and after reversing the frame of acceleration of the frame of reference, that is a, we will reverse the acceleration of frame of reference and multiply with the mass of the body which we are trying to observe. So we are trying to observe which body? We are trying to observe mass m. So to the mass m, what we will do is that we will be reversing the acceleration vector and multiplying with the mass which we are observing, that is m, and this should give us the pseudo force acting on m. So after reversing a vector, we will get minus a vector and multiplying with the mass of the body which you are observing, that is m, plus all sum of all real forces which was 0, there is no external force acting on it, should be equal to mass times acceleration vector which we will be observing in the frame of reference h dash. As you can see, the calculations would easily align and we would be able to say that okay, now the acceleration of the body should be equal to minus a vector which we are observing. So all this is possible because of a force which we are applied additionally in addition to the real forces. So since this is an additional force, this is not a real force, that's why we choose the term pseudo force. So by doing some examples, let's learn more about it. So the acceleration of block with respect to ground is 0. There is a block. A car is accelerating with an acceleration of 2 meter per second square towards the block. So we have a car, let's say, and we have a block. The block is having a mass of 1 kg and the car is having an acceleration of 2 meters per second square. Find the pseudo force along the direction to be applied on the block. So if we are observing this block of mass 1 kg from the car, there is a person sitting in the car and he is observing this block of mass 1 kg. what pseudo force should be applied on this 1 kg mass to observe it. So we know that to apply the pseudo force, what we did to apply the pseudo force, first we'll write f pseudo vector. So we'll reverse the acceleration of the frame of reference. So my frame of reference is this man. This man is my frame of reference. I am observing from the car, and it is accelerating with an acceleration 2 meter per second square. So I'll reverse this acceleration. So let's say the rightward direction is positive, so I will write minus 2 meter per second square. So minus 2 meter per second square. So I have reversed the acceleration and I multiplied with the mass I am trying to observe. So I am observing mass 1 kg. So I'll apply the multiply this with the mass I am trying to observe. So we'll multiply this acceleration with the 1 kg mass. So we get minus 2 newtons, and we can write the direction minus I cap. So that direction is taken care of. So this is the pseudo force which would be applying on this 1 kg mass. So here again I would like to emphasize on one more point. As we have learned here is that when we are going with some acceleration a and trying to observe something which is kept on the ground or moving on ground, then to adjust our observations in for that particular body, we'll reverse our acceleration and multiply our acceleration with the mass which we are trying to observe. So imagine that this car which is moving with an acceleration 2 meter per second square, now it is moving with a velocity of 2 meter per second. So its observation would be the 1 kg mass is moving towards it with a velocity 2 meter per second. So is Newton's first law valid in this case? That is, when I am observing from the car which is moving with the speed of 2 meter per second. Now I would see the mass 1 kg moving towards me with a velocity of 2 meter per second. So you would say the acceleration of the 1 kg mass would be 0, since it's moving with no acceleration or whatsoever, and there is no net force acting on it. So you would say that you are a inertial frame of reference. That's why Newton's first law is applicable on that 1 kg mass. So it's not necessary that all moving frames of reference are non-inertial frame of reference. A frame of reference is non-inertial only when it has some acceleration, non-zero acceleration, or it is rotating. Only then pseudo force comes in play. Otherwise, pseudo force does not have any need. Okay, let's move ahead. So let us do one more question to understand. So the pseudo force which is to be applied on a block, this is what we did in the last question. Now let us do this example. A block is attached to an elevator ceiling as shown in the figure. So we have an elevator, and in the elevator you have a man who is trying to observe this block which is tied to the ceiling like this. Basically we would be asked to find what is the tension acting in the string if the elevator is going up with an acceleration of 5 meter per second. The acceleration, the elevator is going up with an acceleration of 5 meter per second. The mass of the block is 1 kg, m is given as 1 kg, and g is some 10 meter per second square. So what would be the tension in the string? So first of all, let us think that whether our frame of reference is non-inertial one or an inertial one. So we are going up with an acceleration of 5 meter per second square. That means we are an non-inertial frame of reference, and since we are non-inertial frame of reference, we would be having to apply the pseudo force on the mass m. So let us draw all the existing forces on the mass m, all the real forces on the mass m. The real forces on the mass m are T and mg, and we'd say that to apply pseudo force, what we have been doing is that we'll reverse our acceleration So we'll reverse this acceleration, so the acceleration would be in downward direction, and multiply with the mass I am trying to observe. So I am trying to observe this mass m, and I multiply the mass m with the acceleration with which the frame of reference is moving, and I have reversed this direction since the frame of reference is moving upwards with an acceleration 5 meter per second square. The pseudo force is in downward direction. So these are all the forces acting on the mass m in the frame of reference of this person. So let's say with respect to this person, the mass m is at rest, it is not moving at all. So we'd say all the forces are in balancing. So we'd say tension is equal to mg plus ma, or we'd say tension is equal to m into g plus a. So it's a mass of the block is some 1 kg and g plus a is some 15 meter per second square. So this should give us the tension in the string to be equal to 50 newtons. So in the next video we will be continuing from this point only and doing more problems. And in this video, in this particular video we have covered the topic of pseudo force and its idea, how to apply pseudo force in simple cases, and its application, or whether it's a non-inertial, how to apply what a non-inertial frame of reference, whether to apply pseudo force in inertial, non-inertial frame of reference. That is what we learned. So thank you for joining and have a nice day.